Bom, pessoal, bom dia. Obrigado pela vinda de todos aqui. Aqui está mais quentinho que lá fora, né? Vamos usar o nosso calor humano aqui. Mais uma vez, muito obrigado pela vinda de todas vocês. A exemplo do que nós fizemos há 2 anos atrás, acho que algumas estavam aqui presentes também, quando o Mark e o colega dele, Doug, deram uma palestra, não nesse local aqui, mas no outro auditório, sobre Endozyme BioClean e sistema ATP de validação de limpeza. E esse ano temos essa honra de poder trazê-los aqui de novo para uma palestra que eu acredito que será de grande utilidade. Vocês vão aproveitar bastante e no final dela nós abriremos para perguntas. 2 assistentes estarão ao lado, de cada lado das cadeiras, com os microfones para que vocês façam as devidas perguntas. Bom, o Mark Eskener, que está aqui do meu lado, ele é químico-chefe e vice-presidente de pesquisa e desenvolvimento da Ruhoff Corporation. Então, ele entende do que ele vai falar. Os assuntos que serão hoje aqui cobertos são assuntos bastante atuais e que também são de grande interesse da Ruhoff. Hoje o Brasil lidera o que diz respeito a normatizações, sem dúvida nenhuma, sobre detergente enzimático. É inédito no mundo o que a RDC 55 fez e importantíssimo o que a Anvisa realizou. A RDC 15, a RDC 6, e isso, a nível mundial, é inédito. Tá? Isso também será abordado pelo Mark. Também, da Ruhoff Corporation, nós temos aqui também o Sr. Frank Bass, que é presidente e fundador, um dos fundadores da Ruhoff. Há 37 anos inovou no mercado mundial a utilização de detergente enzimático na área médica hospitalar. Estamos também aqui com a presença do Sr. José Obregon, da Ruhoff Corporation também, diretor internacional da companhia. Bem, vamos passar ao que nos trouxe aqui, que é a palestra do Sr. Mark Eskener. E logo depois, então, quando ele encerrar, nós passaremos para as perguntas.
Oops. Good afternoon, hello, and welcome to SOBEC. My name is Mark Eskener. I'm Vice President of Research and Development at Ruhoff. I've been working there for the past 16 years. I've had many opportunities to go into hospitals, to see the processes, to see if they're following the standards for reprocessing instruments. And from my visits, I was able to better gauge how to formulate detergents that are going to work optimally under the worst conditions. I last had the opportunity to visit Brazil 2011, and I gave a presentation on Ruhoff BioClean, which is a neutral pH enzymatic detergent that was specifically designed to remove biofilm from inside of endoscopes. Just a little bit about myself. I live in New York City. I've born there, lived there my whole life. I have a couple of kids. My last visit to Sao Paulo, Juarez and myself had the opportunity to visit the municipal stadium, and I had a chance to take a shot on goal, and I scored, and I shot 65 kilometers an hour. And my son, who's a big fan of the Brazilian national team, his name is Henry, was very proud of me. So I said, this time when I come back, hopefully I could shoot a little faster. We've been practicing. Here you can see the founding fathers of our company. We have Frank Bass, who is here with us today, and Bernard Eskener, who is also my father and my mentor. And we've worked closely together. He designed the products originally in 1976, and when I came into the company, it was my challenge to make them better. And again, going out to the field, visiting professionals like yourself, gave me the inspiration to improve the products. Also, in this slide, you could see we distribute to almost 48 countries around the world, and I've had the opportunity to do the registration process in each of those countries, so I'm completely aware of what standards exist and what's required for instrumentation and detergents. When we first started out, we had one product, one enzyme product, which was a powder. It's called Protozyme. And as the challenges of cleaning were better defined, we improved upon which products we needed to design for the industry. Today, we make products in addition to the enzymatics, such as cleaning brushes, sponges, preparatory sprays, and also cleaning validation equipment, such as the ATP system and the Clean Check Complete. Every day you have challenges to deal with, and we want to help you meet those challenges, and that's why I'm here today, to talk about the challenges associated with enzymatic detergents, the registration process, the qualification of a type of enzymatic detergent, and also cleaning verification. So when you first walked in here, you received a magnifying glass, and you may be wondering why we presented you with this magnifying glass. And the reason we did that was to remind you to take a closer look at your cleaning challenges as they relate to RDC 55, a new enzymatic detergent registration required by ANVISA. But we'd also like you to take a closer look at what makes up an effective enzymatic detergent and how you can verify the cleaning process. Brazil is the very first country to actually develop and institute a registration or a standard for enzymatic detergents. And like I said, having gone through more than 40 registration processes, this is the first time I actually see standards and criteria set for detergents. I think it's fantastic, and I think that Brazil will be put on the map, certainly for doing this in years to come, and people will be following Brazil on this. So congratulations to Brazil for doing this. Oops. So, and there's also a very good reason why Brazil did this. Not just the reason for the regulation for this enzymatic detergent is for one specific reason, and the reason is hospital-acquired infections are increasing. As the general population and people are getting older in this country, we find that more and more surgical procedures are being done, and as the surgical procedures are being done, there's a need for instruments to be reprocessed and put back into circulation as quickly as possible. And therefore, this could potentially be very dangerous for the next patient who's going to be using the instrument. Getting the instrument back to the doctor is not an easy task. For example, endoscopes are very, very difficult to clean. You have the air, water, the biopsy, the elevated guide wire channels. These are all channels that need to be cleaned and addressed. There are so many different types of scopes that to know how to clean each one is a big task. In the United States, our problem is the lack of certification, the lack of standardization. Technicians who are cleaning these devices are not certified. And by creating standards such as RDC 55, it's going to also ask for higher standards for the reprocessing. But again, I don't want it to limit just to scopes. There are thousands of types of instruments, complex and not so complex, and they all have their own cleaning requirements. And it's up to the device manufacturer to develop proper instructions for use to reprocess these instruments. And so it's about collaboration between the medical device manufacturer, the people in your department, and anybody who's providing an accessory to the reprocessing of that device, such as the enzymatic detergent manufacturer. I can't emphasize enough the importance of proper cleaning. Frank Bass, our president, said it best back in 1976. You can clean without disinfecting, but you cannot disinfect without cleaning. If an instrument has not been thoroughly cleaned, it hasn't been taken apart, an arthroscopic shaver, very difficult to clean. If you don't clean it effectively, there's no chance of disinfecting it or sterilizing it. So it's very important that you must be able to clean the instrument. I'd like to thank Frank for saying these words, because his saying has been adopted by most central sterile departments throughout the United States, and it's also become the philosophy of many regulatory guidelines that I've come across in my registration process. What you see here is a picture of a woman pulling her hair out. And the reason for it is that as a member of the Central Service Department, you're confronted with so many obstacles, you just can't get your job done. And you have the right to be frustrated, confused, or feel that your needs are not being addressed. Because obviously you're dealing with hospital administrators and their budgets, you're dealing with doctors and their need to get the instrument back, and at the same time critiquing negatively maybe the cleaning process. You have very complex instrumentation that has very specific cleaning requirements, which takes a long time. You have different types of soil like biofilm and bioburden, and you need to know how to best remove these soils from the instruments. You also have materials managers who do the purchasing of the enzymatic detergents, and they don't necessarily realize what your problems may be. They'll make a selection for you just based on price or what fits best into their schedule, or if they combine a bunch of products together. So it's important to also get all these components on board to understand what you're trying to achieve in your department, ultimately to lower hospital-acquired infections. RDC 55 is a new regulation and registration process for Brazil for the acceptance and use of enzymatic detergents used only in healthcare industry, healthcare industry and in facilities, and it's only for enzymatic detergents that will be used to clean surgical equipment. What are the key points of RDC 55? RDC 55 provides a list of definitions, such as what is an enzymatic detergent, for cleaning medical devices, instructions for use, general labeling requirements. It also goes into describing what are enzymes and what is enzyme activity. And without getting too technical, these definitions will provide you a basic framework of what kind of requirements you'll have to deal with. The chapters on general characteristics and technical requirements cover areas regarding the intended use on medical devices and the fact that it should comprise at least one enzyme, namely protease, to hydrolyze proteins or the peptide bonds associated with proteinaceous soils. It also must not be harmful to the environment or to the patient or the healthcare provider or professional. Finally, the enzyme in the detergent must be stable for the duration of the shelf life of the product. So basically, the enzyme needs to be stable not only in the concentrated form, but also at the dilution. Whatever the dilution may be, it still has to have enzyme activity at the end of its shelf life in that minimal dilution. To me, what really stands out with this regulation is the importance of the minimum enzyme activity testing. RDC 55 requires that this be determined by an independent government laboratory. What will be determined is the at-use dilution of the detergent at the end of the shelf life period, and this enzyme activity, like I said, will be required to be printed on the label, so you'll be able to see that this product has met the ANVISA regulation for RDC 55. In this slide, I just want to point out, and it's important to note that enzyme activity does not necessarily equal product performance. It's important in the RDC 55 to show that you have enzyme activity throughout the duration of the product life, because the enzymes are what's doing the work. But in order for the enzyme to actually do its work, it needs to penetrate soil. And there are other types of chemicals that go into a detergent, such as surfactants. Surfactants are there to break down the soil on a medical device. So, let's see. Now, I'll go for my notes. As you can see, the enzyme activity, as reported by 2 different labs in Brazil, both Anvisa certified, for the same product, the same batch, are significantly different using the same test method as prescribed in the RDC 55. So here you see lab 1, protease activity, amylase activity. Lab 2, protease activity, amylase activity. This is the same lot, same batch of material for the first lab and the second lab. You can see the concentration from lab 1 is twice the amount as in lab 2. For the amylase activity, lab 1 had 0.03 activity as compared to 0.43 activity. And you're asking yourself, what does this mean to me? Why does this matter? It matters because, again, I just want to point out that the science is not perfect. It's more of a qualitative method than quantitative. But the point is, the enzyme can be determined, but you can't just look at these numbers and take 2 bottles and put them together and say, well, one has more enzyme activity, therefore it's better, and this is the only selection criteria I'm going to look out for picking out a detergent. Could be that our product has more detergent, more enzyme than our competitors, or our competitors could have more than us. For us, it doesn't make a difference, because what we really want to look at is product efficacy. And like I said, enzyme activity is not going to tell you about the product performance. This is not to say that RDC 55 is not a step in the right direction. It certainly is great in that it will require companies to register and have their products evaluated prior to being sold and put into your facilities. What I'd like to address with you at this time are the qualities you should look for in selecting an effective enzymatic detergent for your facility. Qualities that have not been detailed in RDC 55. In this picture, you could see the Brazilian national team, our product, some raw materials, ingredients that go into the product, and also some of the factors that affect product quality and to qualify the product. At this time, I want to congratulate the Brazilian national team for winning the Confederation Cup. This wasn't an easy accomplishment because it's a young team, it's a new team, but also the directors of the team had to select the best players, and they also had to select the best combination of players. The two ideas go together. The same applies for developing an effective enzymatic detergent. Not only must you select the best chemicals, but you also have to make sure you select the best combination of chemicals to build a winning product. It's like what I said before. You could have so many different types of instruments, and they have different cleaning requirements, different types of soils, different types of processes for taking them apart. And there's a lot of things and a lot of time and effort goes into selecting the surfactants that will best allow an enzyme to do its job. Because what the surface active agent does is it breaks down the barrier. An enzyme will only function if it comes in contact with the material it needs to break down. Without breaking down the surface tension surrounding that soil, the enzyme will never do its job. So you could have a lot of enzymes. Without the right chemistry, the enzymes will never work. So, and like I said, you can't have just an enzyme alone. You need to combine the enzyme with the right surfactants, target specific soils, work within varying processes, and our challenge is to design a product that is effective during the cleaning process, effective on different types of medical devices, easy for the end user, environmentally safe, economic, cost-effective, and validated by an independent laboratory, most certainly an ANVISA or a certified laboratory, to be effective in the cleaning process. And I'll follow with the review on each one of these characteristics and a few more details on the next few slides. So let's start off with cleaning methodologies. Our products are used in various types of cleaning methods and machines. There's the manual cleaning process, there's the mechanical or the ultrasonic. There's also what's called an AER, which is an automatic endoscope reprocessor. And of course, the washer disinfector, I'm sure everybody's familiar with that. Each type of method or device is very different, and when formulating a product, we look to take into account the product that must function optimally in each scenario. In the manual cleaning, some people brush, some people soak. And the AERs work by flushing the solution and spraying the solution within the chamber. Ultrasonics work on the ultrasonic waves. And of course, washer disinfectors vary very differently. Some are low impingement, some are very powerful. Some also work with high heat. So the function of all these different types of washer disinfectors is different. And therefore, we have to formulate a product that's going to work in all those conditions. It's not an easy task. And because of the very nature of the product, the enzymatic detergent, it will function very differently. But we want the same result in the end, a cleaned instrument. We also have to look at specific types of medical devices. There are so many different types of medical instrumentation. And what are some of the challenges we confront here? The challenges center around the different types of soil based on the types of procedures. For example, soil from an upper GI is extremely different than soil from a lower GI. And the surfactants we use in our products to make one product that works for everything, the surfactants we use have to be complete enough to target all those types of soils to break them down, again, so the enzyme can do its job. Enzymes alone will not make a determination if a product's going to work. You need to have a product that's formulated for all different types of medical devices. Getting into even more difficult to clean are arthroscopic tools, orthopedic tools, things that go through bone, fat, blood, everything. It makes it very difficult to clean. And again, as the doctors require instrumentation that's even more complex to do their job, it's just as complex to clean them. It used to be that cleaning an instrument was as simple as just taking a brush, soaking it, and brushing it a little bit. Now you have to be able to, it's almost like a laboratory. You have to know how to take it apart, clean it. Some parts need to be cleaned in an ultrasonic, some manually, and then reassemble it before it goes into use. It's very complicated and it's a time-consuming effort. At RUHOF, we've designed our enzymatic detergents to work in the worst-case scenarios, in a situation where the instrument may have not been taken apart. And some orthopedic and laparoscopic instruments need to be manually washed, then put through ultrasonic, as I described before. What we hope for is that even if you miss one of these steps, our enzymatic detergent works well enough for you that it will still mitigate the chance or lessen the chance of that instrument passing on or transmitting an infection. User-friendliness and safety. The product you select and the product we formulated for you must be safe, very user-friendly, and our products already comply with RDC 55 standard. We are going through the registration process, but we still comply with what's detailed in the standard. In addition, all RUHOF products have full instructions for use on the label, which also detail necessary information on step-by-step directions on how to best use the product. When designing the product, we considered your other needs, your time constraints. Your time constraints. We understand that you need to clean the instrument right, and you need to clean it right the first time. Otherwise, you waste so much time in re-cleaning. Your budgetary considerations. We know the importance of your bottom line, and so developed an enzymatic detergent, which is very ultra-concentrated with low dilution so that you have something that's very cost-effective in the long run for your budgets. We know that you spend a lot of money on your medical instruments and that you don't necessarily have it in your budget to keep replacing instruments as they get, if they get damaged. So a product that's non-corrosive and very safe to use on your instruments will actually enhance the life and efficiency of your instrumentation. We also understand that it's important for an enzymatic detergent to be non-irritating, safe to the end user, and safe to the person doing the cleaning. A lot of times with enzymatic detergents, they're formulated in such a way that they could be sensitizing or an irritation to the skin. Again, we've had a lot of testing done to show it's non-irritant, and we don't need to include symbols on our product for the RDC 55 regulation. We also understand that it's important for enzymatic detergents to be, in addition to being non-corrosive, they need to be neutral pH and non-irritating. We even had these features tested, like I said, in the Brazilian lab. You also want to keep your doctors happy. Your physicians, you want your physicians to be able to do their surgeries with confidence that the instruments they are using are clean. The doctor certainly doesn't want to have to flash sterilize or send the instruments back for reprocessing and cancel a surgery. It could be very costly to the facility. Finally, your ultimate goal and your main goal is selecting the right enzymatic detergent to lower the chance of the hospital, or to lower the chance of a patient getting a hospital-acquired infection due to an improperly or ineffectively cleaned instrument. We also, when formulating a detergent for your use, look at being non-harmful to the forest, being non-toxic to waste streams, also being non-toxic to aquatic organisms. So you can feel confident that once you've finished and you've discharged the solution in the drain, that it's going to biodegrade quickly and, again, not affect wildlife. So basically, just to go into a review, when selecting a product for your organization, the certain factors to consider is cleaning methodologies, types of instrument, type of machines you wash it in, medical device types, arthroscopic, endoscopes, they're also different, user-friendliness, environmental awareness, and you most definitely want to take into consideration all these factors when selecting an enzymatic detergent. Now, anybody can make claims or marketing claims on their label that they have all these great features built into their product, and anyone can make these statements in their advertisements or claim that they have these features when approaching product selection committees, but the question is, do they have the testing to back it up? Do they have validation testing? Do they have testing to say the product is making the claims, can do what we're making as claims on our marketing information? Everyone registered and complying with RDC 55 will have to have enzyme activity, which is great. However, RDC 55 will not require them to provide product performance or efficacy. They don't need to show you that these products are effective at ultra-low concentrations. They don't need to show you that they're effective at the end of the shelf life. They don't need to prove that they're non-toxic, non-corrosive, and biodegradable. All these things are wonderful things to say about your product, but they have to be proven, and they need to have validation studies. RUF products have all these validation studies completed. So again, when selecting a detergent, look beyond the label, ask about product quality and testing and validation studies. One of the studies to go into some of the testing that we've done, that we've performed, we used a company in France, Biotech Germande. They did a biofilm test. We used Undesign BioClean, and what we did was we tried to figure out, well, the ISO standard, the ISO 15883 standard, Annex F, states that you need to be able to remove greater than 90% of proteins in less than 15 minutes. We were able to achieve that in less than 10 minutes at a dilution of 4 mils per liter, which is, we're the only company currently in the world that can comply with this standard as an enzymatic detergent. So we're very proud of that. Another testing laboratory we use is Nelson Laboratories. We want to say that we're the most concentrated, but we want to say that we're the most effective at that concentration. So to be able to prove this, we did a study with Nelson Laboratories with Endozyme XP and a Steris 4-cube washer, the Steris 444. We were able to use a very, very low dilution, and within the first 2 minutes of the wash, pass a TOSI test, but also achieve a log 5 reduction on 3 coupons that were soiled with a challenge organism. So we achieved a 5 log reduction and a 99.99% removal of the bioburden in just 2 minutes, the first 2 minutes of the washer disinfector cycle. It's not even going through the thermal phase, so we're very proud with this result. Again, you could see the results from that test. Here are 3 different tests, the 99.99% reduction, the 5 log reduction, and also we had that test done at the same time we were cleaning these coupons. We had the TOSI test in the washer, and all the TOSI tests achieved a 0. 0 is the best result you could possibly do. Again, this is at a very low dilution, 2 minutes in a washer disinfector without going through the thermal phase. So it is really impressive. We were happy with this result. Another system that we've used to compare our products versus an alkaline product is the ProReveal system that was developed by Dr. Nanda Nayuni. He's a bioanalysis chemist at the William Harvey Research Institute in London. What this test shows is the ability for, it's a comparison between an enzymatic detergent, our Endozyme XP, and an alkaline detergent, and its ability to remove protein soils from an instrument. So we did scissors and forceps. And what we found during the process was that we were able to quantify the amount of residual protein. In this graph, you could see the amount of protein remaining for the enzyme wash was significantly less than for the alkaline wash. And also on this instrument here, you could see much less. What makes this test so interesting is that this data is collected not from a residue, but from a photograph. Dr. Nanda Nayuni's protocol actually takes a photograph of the instrument that's just been reprocessed. It highlights the remaining bioburden and also quantifies it using these peaks. And that's how we were able to do the determination. You could see here the initial amount of protein was 986 micrograms. After an alkaline wash, the remaining protein was 103 micrograms. With the Endozyme XP, you could see 9.4 micrograms remaining, which is, again, substantially less and something we're very proud about, and we were happy to see this result. This result was actually independent, and we were informed about it before we even knew of the technology. So, again, something that we were happy to see. We also do testing here in Brazil. We use BioNCEOs, a local Brazilian laboratory, to do corrosive testing on certain types of metals when exposed to XP. This is important because you want to make sure you're using a detergent that's not going to be corrosive to your instrument. Now, what's interesting on this result is that if you have these metals here, free from contact with the detergent, total immersion of the instrument in detergent. So free from contact means it's just sitting out on a shelf exposed to air. The amount of corrosion sitting in the air was greater than the amount of corrosion when sitting in our product in the concentrated form, which is amazing. So our product actually preserves the instrument and extends the shelf life when compared. So it's actually better to store the product in store the instrument in our product rather than letting it sit in the air. So again, something that just shows how effective it is at being non-corrosive to the instrument. Again, this isn't something we expected when we started the test, so we're really happy to see this result. Equalizer Group, another Anvisa-approved laboratory. We did some irritation testing here, and you could see from the results that, that on a scale of 0 to 110, our result was actually 2. So it was at a level so low that according to the RDC 55 standard, we don't need to put a corrosive or irritant, for both these tests, we don't need to put an irritant sticker on our bottle or a corrosive sticker on the bottle. So we're very pleased with these results. Just a little more, there's other standards that we want to comply with. Joe Lewingling from Amy is here today. He gave a presentation earlier about standards and him wanting to adopt more of the Brazilian standards because, again, you're very progressive and you have very detailed standards, which is really nice. The FDA we comply with. We also comply with European directives and also ISO directives. Again, these are so many different directives, so many different ideas from so many different people and organizations around the world. Our goal is to try to, because we export to so many countries, to try to comply with all of these as best we can. So more specifically with Amy, it's important. They make a list of what's important and what should be considered, and possibly moving forward, RDC 55 could look at some of these things as factors to be certified or standardized in the selection of an enzymatic detergent. Again, being non-abrasive, low foaming, free rinsing, biodegradable. It should be able to rapidly dissolve soils, non-toxic, be effective on the specific types of soils, and have a long shelf life and be cost-effective. Verification of cleaning. So, what is the key component of RDC 15? And another what is the key component of RDC 15? Another 2012 resolution requiring good practice for processing of health products. To sum it up, RDC 15 requires cleaning validation stating health products, whether manual or automated, should be assessed by visual inspection with the aid of image intensifier lenses. At least 8 times increase supplemented as indicated by chemical tests available on the market. So what does that mean? Basically, they're saying take a cleaned instrument, take a magnifying glass, look at it, and see if it's clean. That's great. You know, you could see visually, but sometimes you can't. Sometimes a microorganism is smaller than can be detected by the eye. So we have other test methods that we could look at and use to verify the cleaning process. We have ATP Complete, which is the ATP system, and also the Clean Check Complete. What is ATP Complete? ATP Complete is a rapid, simple, and reliable method for verifying the effectiveness of the cleaning process on all hospital surfaces, not just surgical equipment. So you could test the inside of a scope. Currently, we are the only provider of an ATP system that has the ability to sample the inside of a scope without flushing. We actually have a test issue sponge, this device here, that we could insert into a scope and take a real sample from it and a measurement. We've used this in the VA hospitals in the United States, and it's been adopted by 100% of the facilities and for 100% compliance. So each scope is getting tested with this method, not just 1 in 20, every single scope. They've actually identified a number of scopes that were passing leak tests, but could not be cleaned. And it turned out to be micro fissures inside the lining of the scope. So we were able to make a determination of whether or not something was clean using this method. We also have a study going on with Dr. Michelle Alpha And at St. Boniface Hospital, she's accepted our testing protocol. We're doing a 2-phase study. The first phase is to verify that using the test industry sponge is the best method for collecting ATP and sampling and verifying the cleaning process from within an endoscope. We also are verifying the cutoff range, 45, which is the lowest RLU range currently set from any company. We also have a process of verifying your cleaning machinery. We have the Ruhoff Clean Check Complete. Does 4 things. 1, it makes sure this test, if you pass this test, it will let you know that you've had the right amount of enzyme, you've had the right temperature, the right amount of mechanical action, and the right amount of duration, the right amount of contact time. So if you pass this test, you've passed the cleaning process. And again, it just verifies the cleaning process. It'll say that the ultrasonic is working, that the machine is working, and the likelihood of your instruments being clean is very good. So this is my last slide. I know it's kind of a long presentation, but there's a lot to cover. I like to say that at the end of a presentation or end of a training session that we do in our own facilities, what is the takeaway? What are you going to leave here with today? You know, you spent a lot of your time here, and I want you to leave knowing something new that I feel like you've taken away an idea that you could use in your facility. So to sum it up, RDC 55 and RDC 15 are definitely steps in the right direction because they will give you standardization and regulation on the types of products that are going to be offered in your market. RDC 55, again, will cover whether or not the enzymatic detergent being provided will show enzyme activity throughout the duration of its shelf life. But it's not going to go into the areas of whether or not the product is effective. RDC 15 will give you guidance that you should look at a cleaned instrument under a magnifying glass to verify clean. But you should be taking other steps to monitor the entire batch process and not just the individual instrument, using new technologies such as ATP Complete and Clean Check Complete to accomplish this task. We also want you to look at product quality. We previously discussed that a quality product will be a product that conforms to association guidelines, such as those for the Association for the Advancement of Medical Instrumentation, which is AAMI. Another key takeaway is that a quality product will have validation testing proving its cleaning efficacy. RDC 55 indicates that the registered product is regulated, but you just can't look at the enzyme activity alone on the product label. You can't compare 2 products and say one product is better based on the enzyme activity listed on the bottle. We want you to question the product and the claims on the label. You want validation testing. It's effective in the different cleaning methodologies, on different types of soils, on different types of medical instruments. You have the choice to improve your overall cleaning and verification processes. RDC 55 will make sure you're getting a product that has enzyme activity. But again, it's not going to tell you the whole picture. You still want the product qualifications and validation testing. Like I said, at Ruhoff, we've gone through these validation studies, we've gone through these verification processes, and we continuously innovate to create solutions to make your life easier. Ruhoff does have the product lines to help you improve patient safety, cut down on HAIs, hospital-acquired infections. One last thing to take away, we also gave you these Ruhoff magnifiers as a reminder that when you return to your facilities, take a closer look at how you're choosing a cleaning product. Take a closer look at your cleaning processes. And as a reminder to contact Ruhoff if you have any questions regarding any of these things. Again, I want to just take the time to thank Juarez from Planet Trade for giving me the opportunity to express our thoughts here and to help maybe give you some guidance in the selection of an enzymatic detergent. Thank you.
Bom, Mark, muito obrigado. Vocês desculpem alguns erros da tradução dos slides aí, que foram apresentados em português, para facilitar também que vocês sigam as ideias do palestrante, mas eu acho que ajudou bastante. Bom, estamos abertos para perguntas aqui ao Mark. E nós temos duas assistentes aqui ao lado para que vocês possam fazer uso do microfone e fazer as perguntas.
Mark.
Alguém tem pergunta? Eu tenho uma.
Mark, muito obrigada por sua apresentação, muito esclarecedora para nós. Eu gostaria de saber se um produto apresenta um pH 7, no caso neutro.
Só um minuto. Desculpe, por favor, pode repetir?
Então, Mark, muito obrigada por sua apresentação, muito esclarecedora para nós. Eu queria saber de você, no caso, é um produto que apresente pH neutro, 7, e que mesmo assim apresente espuma, em que ele vai ser negativo, prejudicial, ou para o maquinário ou para o nosso instrumental?
Okay, a great question. You have a product that has a neutral pH, but it tends to foam too much in a machine. What effect is that going to have on the machine? It's going to slow down the pumping action. If it's a machine like a washer disinfector, which circulates the solution, it's going to slow down the process and put a lot of stress on the pumps. In this situation, if the product you're using has a non-ionic detergent, it will state on the bottle a temperature to wash at, which is optimal. That temperature will be above the cloud point or above the foaming nature of the product, making the product not foam. So it's important to look at the temperature that you're washing at to reduce the amount of foam you have in the machine. And then it'll work effectively.
Eu gostaria de complementar também. Nós temos muitos problemas que nós vemos nos hospitais aí Brasil afora pela espuma. A espuma também representa a ausência de contato do detergente com os materiais. Então, além de fazer um esforço demasiado nas máquinas e fazer com que elas estraguem, você não está obtendo o contato do produto com o artigo, devido a ar. Espuma é ar. Então, você não está tendo contato. E isso é uma coisa que nós vemos muito no mercado brasileiro. São produtos que fazem muita espuma quando submetidos a uso em máquinas termodesinfectadoras. Então, tem essa questão também da eficácia da limpeza pela presença da espuma, que é uma característica, Mark, que nós achamos muito no mercado brasileiro. São produtos que fazem muita espuma. Ok? Mais alguma pergunta? Eu tenho uma pergunta que eu acho que vai ser útil para que vocês vejam a resposta. Por que a Ruhoff estabeleceu como limite de leitura de ATP o número 45? Né? Nós recomendamos que o limite aprovado de um artigo submetido à leitura de ATP seja 45. Né? Existem outras marcas e outras marcas de ATP que instituíram um valor mais elevado que esse. Mas eu queria saber da Ruhoff, do Mark, por que o estabelecimento do número 45 como limite?
Okay, actually included, I'm asked this question every single time, so I've included a couple of slides here just to go over a validation study we did to set the marker or the cutoff for 45. Just to make it really simple, we've compared the ATP system, the results, to hemoglobin testing, protein testing, and total organic carbon testing. At the minimum detection level for toxic organic carbon, total organic carbon, protein testing, and hemoglobin, the ATP RLU reading was still 56 to 79. So we could have stopped there and just make the determinant as 56. But by doing all these cleaning processes on all these types of instruments, we were able to successfully reproduce the result of 45, which is well below the detection limits of other commercially available devices.
And with our products.
Right, using our products, we were able to achieve this level. So that's how we made the determination of 45. Other devices, I believe, are effective maybe up to 200. But again, 200 will not even be close to the minimum detection level of hemoglobin, protein, or total organic carbon. So we're really happy with this result.
Acho que isso responde uma dúvida que muita gente tem isso constantemente. Por que 45? Por que não 500? Por que não 700? E a conclusão que nós chegamos, e isso também foi obtido nos hospitais de veteranos nos Estados Unidos, e que a RUHOF recomenda, quanto menor o número, a quantidade de ATP encontrada, mais segurança você vai ter. Né? Se você pode obter um número inferior a 45, por que você vai se satisfazer com 600, 400, 500, se você consegue chegar a um número inferior a 45? Mais uma vez, você não está medindo uma contaminação ou uma bactéria específica. Você está reduzindo as chances de ocorrência de. Então, quanto menor o número, mais satisfatório está o seu processo. Ok? Alguma pergunta a mais?
Marcos, muito obrigada pela apresentação. E muito obrigado por elogiar a RDC 55. Eu sou uma das mães da RDC 55. E aproveitando aqui que eu estou com o microfone, convidar todo mundo para assistir a minha palestra amanhã, no 12h15, na sala 4, que eu vou falar dos enzimáticos. Mas eu queria saber de você se nos Estados Unidos tem detergente enzimático com antimicrobiano, porque a gente fala em eficácia, né? E nós falamos em atividade. No Brasil, nós falamos em atividade das enzimas. Se tem com antimicrobiano e como que é isso? Se o antimicrobiano, se você tem algum conhecimento do antimicrobiano, como que ele vai funcionar com a enzima? Se a enzima resiste a essa mistura.
That's such a great question. I love this. It's one of my favorite questions, actually. In the United States, we have the Environmental Protection Agency, the EPA. They provide guidance for pesticidal products, products that are able to kill bacteria. So when a product is antimicrobial or antibacterial, that means it has the ability to kill something. In the US, we cannot make an antibacterial or antimicrobial claim on an enzymatic detergent, specifically because the way the detergent is used is very different depending on if it's used manually in an ultrasonic or in a washer disinfector. The way an antibacterial detergent works, it needs a very specific concentration and extremely specific contact time. So if you wash for 2 minutes or soak for 2 minutes, and to be able to clean a certain bacteria takes 5 minutes of contact time, then the product was ineffective, and it's giving false hope or false information to the end user. So in the US, we decided to keep the two processes separate. We clean, and then we disinfect. Because the disinfection or the antibacterial stage has to be for a very specific amount of time at a certain concentration. So we don't combine the two, because it could be misleading.
Tá, só completando, eu queria colocar aqui que no Brasil não é proibido ter um detergente enzimático associado a outra categoria. Tá? A legislação permite isso. Eu só queria entender como que ela resiste, porque nós estamos fazendo a metodologia da lipase e é muito complicado. Ela é muito sensível, por isso que saiu só com as duas.
I agree.
Bom, se não temos mais nenhuma pergunta, encerraremos aqui. Agradeço a presença de todos. Muito obrigado, Mark, pelos esclarecimentos. E um bom congresso a todos.